Now, the reason why this is important, it's important that every real number is the limit of rational numbers. The reason that's important is that it lets me get new functions in a way that I couldn't have before. So for example, this section is all about the exponential functions, and you've probably been working with these for a while now. But what does it mean to take a power of 2, right? 2 to the power 1, that's just 2. 2 to the power 2, that's 4. Sure, why not? And negative powers, okay, those can make sense if a negative power means division. All right, that's okay, fine. Maybe I got taught that at some point and got used to the idea. Oh, and fractional powers, right? I can have a half of a power of 2. What would that be? That would be the square root. And you've probably seen reasons as to why that should be a sensible idea. What on earth is 2 raised to the pi power? Right? If I'm going to have these exponential functions, I better have an answer as to what number 2 to the power pi is supposed to be. Well, here's how we do it. Okay. So I would like to have a function, maybe I have 2 to the power x, where my variable x is in the, the exponent. That's not the reason we have it given that name. It's just a coincidence. So this is different from the squaring function, right? We are not taking x and multiplying it by itself. We are taking 2, and we are copying that 2 x number of times and multiplying them all together. Or at least that's what I would say if x was a whole number, right? I can copy 2 1,000 times and multiply them all together, and that'll be a number. It'll be, I'll call it 2 to the power 1,000. That's a little bit easier than actually calculating that out, but it's a number. I want to have an idea of what number I get from, say, pi copies of 2 multiplied all together. And I can't really do that the same way because pi is, well, first of all, it's not an integer, but I could have done that for rationals. I've already been working with rational exponents for like multiple points in this class. What if I have 2 to a negative power? Well, that's just, say, a half. 2 to the power minus 1 would be a half, because negatives mean division when it comes to exponents. Okay, well, that starts to make sense a little bit. And if I have a rational exponent, x equals p divided by q, then all I have to do is raise my base, 2 to the power p, and then whatever that number is, I'll take the qth root of it, or equivalently, I could do the root first and then raise the power p. But again, what on earth is 2 raised to the power square root of 3? Or 5 raised to the power pi? I better have answers for those things, because at some point I'm going to be taking a function where I say y equals 2 to the power x. X equals pi. What does that even mean? Well, this is what it means. So we can raise 2 to a power of any rational number, right? Any integer divided by integer, p divided by q. And those will all make sense according to our rules for, negative exponents and fractional exponents and all that good stuff. And if I went to graph it, I'd have a graph that's full of holes, a whole bunch of them, because this graph would only exist for the rational values of x, and I know that not every real number is rational. But, this plot is starting to make a fairly suggestive shape. It looks like I should get some kind of a curve. If only I could just fill in those holes, right? How do I fill in the hole of a discontinuous function? I use a limit.